Hi, I'm Glenn Nausley. I'm with Promess Incorporated. I wanted to talk a little bit about a cool application that we've done in the past. This is actually one we did quite a few years ago, and then we've copied it multiple times. And I think this is one of my favorite applications because it's a great example of making something to a function. It's one of Promess's specialties, is being able to measure a part's function as it's being made and actually make the part to a function instead of two dimensions. We talk about this a lot, but this little widget here, which I'm sure does not show up very well on video, so we have a nice picture of it here. Actually, I'm holding it upside down compared to the picture. And basically, this is a pressure relief valve. And it's a very simple item. You have the housing, you have oil pressure here or oil flow, and you got a ball which seals on this seat, and you have a spring here, and it takes a certain amount of pressure that's has enough energy to push this ball down, compress the spring, push the ball down so the fluid can flow around it and flow out the exit orifices. So this, you got the seat, the ball, the spring, and the housing. Very simple part. You can see how small it is. So this particular application, this is for a power steering pump, so that if you crank your power steering all the way over, and the valving on the rack and pinion or the power steering unit closes, that fluid that the pump is pumping has to have someplace to go, and it's dumped over this valve. This particular application, the customer needed this to open at plus or minus 200 psi. It was actually 1,000 psi plus or minus 2. And the operation that they did is basically, this is a small dowel machine. This dowel machine was like this big. And the guy would load the part, it would index over, so it indexed to a idle station. He would put the next part in, and when the operator would load the housing, he'd drop the spring in, drop the ball in, put the seat in, and hit the buttons. This would index back over. So now this one was over here, and there was a press, just a hydraulic press that pushed this down to fixed tooling to a fixed dimension. So the seat was pressed to a fixed location. The next part was loaded, it indexed over. This part that was just pressed would index over to a pressure test station. And they would pump, I believe it was 1.2 liters of oil per minute through into this unit. And at 1.2 liters of flow, it should take 1,000 psi to push the ball down and get flow. So they would do a pressure test, and maybe it would be 900 psi, maybe it would be 1150, it would be 1050, and these would all be passing parts they'd go through. With this technology, they had high variability, usually around plus or minus 100 psi. Now, what happened is this was a sub-supplier to an automotive company, or an automotive company making these steering systems. The people making the steering systems came back and said, we don't want a plus or minus 100, we want plus or minus 50 psi. And this operation wouldn't do it. So what are the critical things? So the first thing the customer did is they said, okay, the question on this, as far as when this opens, if I have a set amount of flow, the variable is spring pressure. More spring pressure takes more pressure. More spring force takes more pressure to open it. Less spring force takes less pressure. That's the variable. So what they started doing was looking into buying more exact springs, machining this housing more accurately, machining this seat more accurately. They were adding cost. The parts got more expensive. They went from a spring that they could buy for 7 cents to a spring that would cost them 27 cents. So doesn't sound like much, but it's triple the cost, 4 times the cost for the spring. Higher precision spring. They still couldn't get to where that they needed to be. So this company, we started working with them for a solution, and what Promess does is we make these servo electric, 100% electric presses. Our standard press, comes with a servo motor with some sort of position feedback on it, so we know where the press is at all times. We have a load cell built in, to it. So just with our standard system and our standard control, we could have pressed to a position just like the hydraulics did. And we could have monitored, which we do very often, what the press fit force is on the seat, and could have said that the seat went in with the proper press force and so on. But as far as quality of the part, we would not have been making a better part, because we're still just pressing this thing to a dimension and hoping that all the parts stack up to give us the function we want. So we worked with at another company and building some fixtures, and we basically the Promess control also has the ability to take in other sensors. So not just the encoder and not just the load cell, but we can bring in probes and pressure transducers and flow transducers and all kinds of different sensors. So the flow on this system, if I go back to the way it used to be, we had a press station and a test station. What we worked with the customer to do is combine these two stations. So at the test station, we pump 1.2 liters of fluid, a fixed amount of fluid flow through the part, and measure what pressure it opens at. Well, if I do that exact same thing, I'm pumping fluid through it. As I'm pressing this, if you can imagine when the guy, the operator assembles this, he puts this into the nest, he drops the spring in, he drops the ball in, and he sets the seat in there. Now the press comes down and presses this seat a little bit, but the spring is still loose. And then we pump fluid through here, and with a loose spring, this thing opens up with almost no pressure. And so as we're pumping fluid through and we're measuring the pressure sensor, we press this seat and continue to press it until we see 1,000 PSI on this seat. That's whatever the target pressure is. So instead of pressing it to a dimension and then testing it and hoping it's good, we press it until it is good. So every single part we're calibrating. And so and this particular customer, they needed a whole plus or minus 50 PSI, I believe was the target. And the first one I ever did, I did the service on this, and we were like plus or minus 2 PSI, plus or minus 1 PSI. It was crazy how accurate it was. 999, 1,000, 1,001, 1,002, 999. I mean, every part. The CPK on this was crazy. So very, very, very accurate in part to part, very repeatable. Every single part being calibrated actually is what it comes down to, calibrating every part. It didn't increase the cycle time. Cycle time was exactly the same. It simplified. We used the same dial station, but we eliminated the idle. We just you load the part, it would spin around, it basically turned it into a 2-station dial, spin around, it would press and test in the same station. And tolerance of plus or minus 50, and the station was capable of plus or minus 2. So we've used this technique of making to a function in a lot of applications. This particular application, after we did it one time, we've recreated it and done it multiple times. But the function of, I've always liked this application because I think it's a perfect example of making to a function. It's a very understandable, but you can take this to other parts. If you have parts that need to be assembled, and you're currently assembling into some tolerances, but you can measure the function of the part while you're making it. One kind of off-the-wall example that totally different but uses the same technology, same idea is we did a job where we were making the visor in a car, the torque it takes to pull it down. It depends on how much a hinge is crimped, and we would exercise the visor as we're crimping the hinge. If you hit a bump on the road and the visor falls down, that's no good. But if it takes me 2 hands to pull the visor down, that's no good either. So you want a certain amount of torque. So we're making to a function. So any part, basically if we can calibrate it as we make it by adding gauging and sensing into the application while it's being pressed or crimped or assembled. That is one of Promess's specialties. If you have an application which you're interested in sharing with Promess and getting our advice on, we have 36 years of experience doing these types of applications. Please feel free to contact us. We have a team of application engineers. You can call us 810-229-9334, or you can go to our website. It's promessinc.com, or email us at sales@promessinc.com. Thank you very much. Please call us if you have an application.